NASA's Explorer-1, the utmost voyaging space apparatus ever sent off, continues its amazing journey through the universe. For nearly 50 years, Explorer-1 has been sending back essential data from the farthest reaches of the universe, significantly advancing our understanding of the cosmos. However, recent transmissions from this remarkable space apparatus have presented astounding signals that have left the entire space community in awe and confusion. These signals have sparked debates about whether they are the result of a technical breakdown or perhaps indicative of something far more extraordinary, like extraterrestrial activity. Join us as we delve deeper into the mystery surrounding these extraordinary transmissions and uncover what might be lurking in the depths of space. Humanity's interest in the mysteries beyond our planet has been a driving force in space exploration since its inception. This insatiable curiosity led to the exceptional launch of missions like Explorer-1 and Voyager-2, which were among the most ambitious space ventures of their time. The launch of Voyager-2 from NASA's Kennedy Space Center on August 21, 1977, marked the beginning of a new era in space exploration. Just 2 weeks later, on September 5th, Explorer-1 followed, paving the way for an extraordinary journey. These twin shuttles, each weighing around 720 kilograms, roughly equivalent to a small car, were launched during a rare alignment of the outer planets, which played a critical role in their trajectories and mission outcomes. Throughout their historic odyssey, these shuttles traveled in different directions and at varying speeds. A key moment occurred on December 15, 1977, when Explorer-1 overtook its twin due to differences in their paths. Since then, Explorer-1 has emerged as an invaluable asset, providing crucial data that has revolutionized our understanding of the universe and its many phenomena. Before we dive into Explorer-1's latest shocking discovery, which has captured the attention of the entire space community, we should revisit some of its most remarkable accomplishments. In 1978, during its Jovian imaging mission, Explorer-1 was approximately 265 million kilometers from Earth. By January 1979, it had embarked on an extraordinary 100-hour mission, capturing a stunning time-lapse film of Jupiter's rotation. This series of 3,750 images provided breathtaking views of Jupiter's dynamic atmosphere and its complex features. The shuttle's discoveries included the detection of a small ring around Jupiter and 2 previously unknown moons, significantly expanding our knowledge of the gas giant's intricate system. To ensure the shuttle's safe passage and avoid potential collisions with Titan, one of Saturn's moons, corrective maneuvers were executed. After the successful Saturn flyby, scientists decided to conclude the planetary missions of both Explorer-1 and Voyager-2. However, the spacecraft were redirected onto new trajectories, venturing beyond the limits of our solar system at a staggering rate of 325 million kilometers per year. In January 1990, the interstellar mission began with Explorer-1 continuing its grand journey. During this period, Explorer-1 made major discoveries, including the identification of 4 additional moons, Mimas, Enceladus, Tethys, and Rhea, and captured some of the most striking images of our solar system. On February 14, 1990, Explorer-1, positioned around 6 billion kilometers from the Sun, embarked on a visual journey known as the Family Portrait, capturing awe-inspiring images of the solar system's planets. This collection of 60 images added to Explorer-1's impressive total of 670 photographs taken during its encounter with Neptune. Voyager-2, likewise, achieved remarkable milestones during its mission. As it approached Neptune, it recorded wind speeds exceeding 13,100 meters per second, the fastest winds ever observed in our solar system. Accomplishment gave critical experiences into Neptune's far-off environment and its largest moon, Triton, which has surface temperatures plunging to a frigid -391 degrees Fahrenheit, making it one of the coldest places in our solar system. Triton also showed remarkable features, including ice volcanoes that erupted nitrogen gas and hurled frozen particles 5 kilometers into its murky atmosphere. These striking revelations have broadened our understanding of the diverse and complex nature of celestial bodies in the outer regions of our planetary system. The Explorer missions have delivered significant and historic results. Explorer-1 and Explorer-2 have revealed that Jupiter and Saturn's moons, once thought to be heavily scarred and inactive, are in fact experiencing geological activity. Explorer 2, in particular, achieved several groundbreaking accomplishments, including being the first spacecraft to fly by Uranus and Neptune, and remains the only spacecraft to have done so. NASA employed various techniques to extend the operational lifespan of these ambitious spacecraft, including shutting down unnecessary instruments and systems to conserve energy. The mission is expected to conclude in 2030, marking a moment of pride and a bit of sadness for the scientists and engineers who have devoted themselves to this remarkable undertaking. The design of Explorer 1 and Explorer 2 was a marvel of engineering. These spacecraft were designed as spinning platforms, rotating at a rate more than 10 times slower than a clock's hour hand. This design decision minimized visual blurring as the spacecraft traversed the vast field of space. Even before reaching the outer planets, the spacecraft began sending images of Jupiter, revealing its swirling clouds and famous feature, the Great Red Spot, a massive storm on Jupiter that captivated audiences at NASA's Jet Propulsion Laboratory. However, the discovery of active volcanoes on Jupiter's moon Io drew the most attention. The spacecraft's instruments detected astounding signals from Io, which were confirmed by stunning images showing towering volcanic plumes and a surface scarred by eruptions. One of Io's most prominent volcanoes erupted with a force several times greater than that of Mount St. Helens, covering an area nearly the size of France. As the spacecraft continued their journey, their cameras were eventually switched off to conserve power and memory before venturing into interstellar space. Notably, the images they captured did not include Mercury or Mars due to various factors. Beyond the Explorer missions, NASA has launched other remarkable spacecraft, including Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Pioneer 10 surpassed Pioneer 11, becoming the spacecraft farthest from Earth. Despite the absence of other space probes to note this achievement, Explorer 1 continued its mission for an additional 14 years before entering the interstellar medium on August 25, 2012. The success of the Explorer missions was made possible through a variety of innovative techniques, with gravity assist maneuvers standing out as particularly brilliant. These maneuvers were crucial for propelling the spacecraft toward their distant destinations and gathering invaluable data. The spacecraft relied not only on their own propulsion systems, but also on gravity assists to achieve their goals. Imagine the two fearless spacecraft smoothly navigating through our solar system, using the gravitational pull of planets to propel themselves forward. This cosmic dance allowed them to conserve fuel and reach the necessary velocities to explore distant regions. Gravity assists involve giving the spacecraft a small amount of a planet's energy as it passes by with extreme precision. For example, as Explorer 1 approached Jupiter, the planet's immense gravitational pull accelerated the spacecraft, boosting its speed. Achieving such precision was critical. Any deviation from the correct angle or speed could have resulted in disaster. Despite the incredible accuracy required, the brilliant minds behind these missions successfully executed these gravity assists time and again, propelling the spacecraft on an extraordinary journey. The brilliant voyage made possible by these celestial maneuvers saw Explorer 2 using gravity assists from Jupiter and Saturn to reach Uranus and Neptune. The success of the Explorer missions owes much to these gravity assists. As we reflect on the stunning journey of these exploratory spacecraft and the wealth of information they have provided, we eagerly await further updates on the investigation into Explorer 1's recent anomalies. Both Explorer 1 and Explorer 2 continue their missions beyond typical boundaries, and their achievements encompass Jupiter and its moons, Saturn and its moons, Uranus and Neptune. Explorer 1's time-lapse images highlight 10 full rotations of Jupiter in striking detail, including the discovery of new moons and a small ring. These findings have greatly enhanced our understanding of Jupiter's complex system. Explorer 1 also discovered 4 additional moons of Saturn, Mimas, Enceladus, Tethys, and Rhea, and captured stunning photographs of Saturn and its rings, providing new insights into Saturn's intricate system. The spacecraft made history by visiting Uranus and Neptune, delivering crucial data about their atmospheres and moons, advancing our comprehension of the outer regions of our solar system. Finishing their planetary missions, Explorer 1 and Explorer 2 wandered into interstellar space, gathering information on the interstellar medium. This continuous investigation keeps on growing our knowledge of the universe beyond our nearby planetary system. As we anticipate more data about Explorer 1's latest signals and their potential implications for how we understand the universe, the astounding journey of these spacecraft remains a source of inspiration and interest for scientists and space enthusiasts alike. Their notable accomplishments continue to push the boundaries of human knowledge and exploration, demonstrating the vast potential of space discovery. The Explorer missions have provided us with a wealth of information about our planetary system and beyond. Beyond the iconic images and data, the spacecraft have also carried a brilliant artifact, an intriguing message designed to share the story of our world with extraterrestrials. This record contains sounds and images selected to represent the diversity of life and culture on Earth. It includes greetings in 55 languages, music from various cultures, and a selection of natural sounds like thunder and whale songs. This message in a bottle, so to speak, reflects the hope that one day, if intelligent life exists elsewhere, they might discover and understand it, offering a glimpse into humanity's essence. Explorer 1 and Explorer 2 were equipped with scientific instruments that have revolutionized our understanding of the universe. These instruments included magnetometers, plasma wave sensors, cosmic ray detectors, and imaging systems, each contributing significant data about space phenomena. For example, the magnetometers have provided insights into the magnetic fields of Jupiter, Saturn, Uranus, and Neptune, revealing the complex interactions between these planets and their surroundings. The plasma wave sensors have helped us understand the nature of the solar wind and its relationship with planetary atmospheres and magnetospheres. One of the most remarkable aspects of the Explorer missions is their ability to measure the heliopause, a massive bubble of solar particles and magnetic fields that encases our solar system. As Explorer 1 approached the edge of this boundary, it detected the sudden transition from the solar wind to the interstellar medium. This data has been instrumental in shaping our understanding of the heliosphere's structure and its role in protecting Earth from cosmic radiation. The spacecraft's observations provided evidence of a distinct boundary where the solar wind slows down and becomes denser, known as the termination shock. Beyond this point lies the heliosheath, an area where the solar wind interacts with the interstellar medium, creating a complex and dynamic environment. Explorer 2's journey has been equally significant. After its successful flybys of Jupiter, Saturn, Uranus, and Neptune, it has continued to provide valuable data about the outer reaches of our solar system. Explorer 2's observations of Uranus were particularly valuable, revealing its unique magnetic field, which is significantly tilted compared to the planet's rotational axis. This discovery challenged existing models of planetary magnetism and prompted further investigation into the magnetic conditions of other celestial bodies. Beyond their scientific contributions, the Explorer missions have had a profound impact on public interest in space exploration. The stunning images of distant planets and their moons, combined with the personal stories of the spacecraft's journeys, have captured the imagination of people around the world. Pictures of Saturn's rings and detailed views of Jupiter's moons, especially Io's volcanic activity, have inspired countless individuals and have been featured in educational materials, documentaries, and popular media. These missions have fostered a sense of wonder and curiosity about the universe, highlighting the importance of exploration and the quest for knowledge. The engineering and logistical accomplishments achieved by the Explorer missions are also noteworthy. The spacecraft were designed to operate in extreme conditions, far from Earth, with temperatures plunging below -220 degrees Celsius. They relied on radioisotope thermoelectric generators, RTGs, for power, providing a reliable energy source despite the vast distance from the Sun. The engineers who designed and built these spacecraft faced numerous challenges, including ensuring that the instruments remained functional for decades and that communication could be maintained over such immense distances. The data returned by the Voyager spacecraft has also played a vital role in our understanding of the wider universe. The spacecraft have helped map the distribution of cosmic rays and have provided insights into the density and composition of interstellar dust. This information is critical for understanding the conditions in the space between stars and for preparing future missions that could explore other star systems. As the Explorer spacecraft continue their journey, into interstellar space. Their legacy is cemented not only by the data they have already provided, but also by the inspiration they offer for future exploration. The missions have paved the way for new advances and philosophies in space science and have set a precedent for ambitious long-term space missions. They demonstrate the possibilities of human ingenuity and the value of perseverance in the face of tremendous challenges. Looking ahead, the Explorer missions have inspired a new generation of spacecraft and mission concepts. Future probes aim to build upon the achievements of the Explorer spacecraft, with the goal of exploring even more distant regions of space. These upcoming missions will continue to push the boundaries of our understanding and will benefit from the foundations laid by the Explorer missions. In conclusion, the Explorer missions represent one of humanity's greatest achievements in space exploration. Their contributions to science, their role in advancing our understanding of the solar system and beyond, and their impact on the public imagination underscore the importance of continued exploration and curiosity. As Explorer 1 and Explorer 2 travel further into the universe, they remain symbols of human ambition and the eternal quest for knowledge.